An open cooling circuit consists of a cooling tower, a pump, heat exchangers and pipes. The circulating cooling water is partially exposed to the ambient air and evaporates there as an important part of the process. The constant evaporation of the water withdraws energy from the environment in the form of heat. The remaining water cools down. It can now be used for cooling. The evaporated water is then constantly replaced by fresh water. Let's take a closer look. Fresh water is never pure. Foreign substances are partly dissolved in water and partly mixed. These are salts, but also calcium and magnesium, for example. When the water evaporates, these foreign substances remain in the residual water. Since this process is constantly repeated, the proportion of foreign substances in the cooling circuit increases steadily. If the concentration of foreign substances in the system becomes too high, part of the cooling water must be drained and replaced by fresh water. This process is called blowdown. Here is an example. Suppose the cooling water contains 1,000 foreign particles per liter. By draining 10% of the water and replacing it with fresh water with 100 foreign particles per liter, the absolute proportion of particles per liter thus drops to 910. The cycle of concentration describes the ratio of the salt content of the cooling water to the fresh water. In our example, we calculate a COC of 10. It can be used to estimate the interval or amount of cooling water to be drained and replaced by fresh water. Find out more about our solution to enhance blowdown intervals with Mirus.